to the cloud. Okay, I'm back, y'all. How y'all been? Did y'all miss me? I've been dying. Like, seriously.
I told you that cold wasn't no joke. I'm telling you.
Yeah, I'm still getting over it. I figure like I can't do no more than a week out. Like, I can't. So here I am,
Yeah, they're gonna be coming back out in 20 years saying COVID had this type of agent in it. Because everybody that catches it, bro, it's like it's hard to get back on your feet. I swear.
Oh, yes, it's been a hard week, like a very hard week. I just went outside today and took a little walk. And I'm like, oh my goodness. Almost
Yeah,
killed me.
yeah, I already know. Trust me.
But I mean, hey, I knew I was gonna catch it at some time. I've been moving around too many people. So if they wasn't gonna say the flu, they was gonna say COVID. So whatever. I guess the flu don't exist anymore.
Nah, straight COVID.
I see. But this was terrible. I mean, when I went to the hospital, I really just needed that my IV, that morphine. And I'm like, okay, that's all I need. And then, rest and pills through the whole week. But whew, I tell you.
I already know. I think my worst day was my first 3 days were the worst because like it was just I was getting body aches bad. My body was sore all over. So and then I had the headaches where you can't turn your head too fast. So
Yep. My whole body was sore. Day one was the 16th. And I'm like, oh, this hurts. That's why I went to the hospital. Like, what's happening? Am I dying?
That's how I feel too, I swear.
Like,
it's like an out-of-body experience.
Yes. That's why I'm like, all week, I'm like, dang, I took for granted how healthy I've been this whole week. Like, it was terrible, but I'm getting better. It's really just like the low remnants. And I'm grateful because, no. I had this before December 2019, right before all of this went down. I had the same feeling and I was dying. I'm like, this ain't a flu, but I ain't go to the hospital. I just was ODing on NyQuil. And then that right when I got over it, then it was like, oh, coronavirus. So, but I'm happy I'm
still got
I'm
all your
down.
senses.
Oh yeah, I had my senses the whole time. I just I couldn't eat anything. I couldn't really walk because my stomach was killing me. I had, it was like the flu just turned up because I had like cold chills and stuff. Like I had a fever. It was, it was really just like the flu, just, on 10.
See, I don't think I ever had the flu. So for me, it was all new. I don't think I ever had the flu.
Well, yeah, that's how the flu feels to me. Like it starts off with cold chills, you ain't really got an appetite, your stomach hurt, and then it just, sickness from there. So that's the flu to me because I get that like, at least before I used to get it like once every couple of years, I would get this feeling. It's just this was turned up. This was turned up for real. So but yeah, but nah. So I know it's been a minute. It's been a week. So we were supposed to go on what? I think. Let me come in here. Let's go to the syllabus. I think it's on IP routing, which we were supposed to do, and then we just stopped there. Let me just see where we need to be at for this here. Okay, yes. So that is. Yep, IP connectivity, 25%. And okay, that's a quick section. So today we're going to talk about how to interpret the components of a routing table and determine how a router makes a forwarding decision. I think these two is good because tomorrow we can do static routing. We can just save that for a whole day. And then we'll talk about routing protocols. Okay, so yeah, we left off on IP connectivity. So let's get into that. I believe, let me go back. Let me see really quick. What did we say? Configure components of wireless LAN. Okay, we'll probably, I don't know, we might want to do that or something. Configure the components of wireless LAN. Let's do that tomorrow as well, because tomorrow is we're only going to configure, which is really just a lab. So we might as well just lab them both out. Because I don't know if you guys did the wireless LAN with the GUI. But you should have. If not, it's cool. We're gonna go over it. But let's hop into it, y'all. Am I recording? Yes. Okay. Let me see. Accessing the network. Oh, we gotta create a whole nother whatchamacallit. First, let me come in here again. Did I put, I didn't put a class for the LAN. Dang, I ain't put a class for this either. All right. It's probably because I didn't upload it to YouTube. All right, so let's do 3. We're gonna say IP connectivity. I think that's what we got going on. I'm gonna just put on this really quick, just so I can put a number 3. Okay, so let's hop into, actually, let me just do this. We're gonna make it a page. Gonna put IP connectivity, and then let's do 3.0, 3.1. What's 3.1? Okay. Boom. The routing table. Actually, I should put it both. 3.1, 3.2. That's what we're gonna talk about. We're halfway there, actually. It's only six sections. And week 3 seems like it's gonna go by pretty quick, so we should be good. Okay, so let's see. We can talk about, was that desktop? Let's talk about routing basics. Upload this so you guys can have it and follow along. And really, I don't, so I don't forget. Routing basics. And then I guess we can do just routing, because the lab I'm gonna give you for labbing. Okay, let's let that load. All right, so routing basics, let me see. That's a lab, we can do that tomorrow. And then we have a routing basics blog. Okay. So let's get into routing. Now, before we even get into it, I want to first just reiterate how a data frame transmit through the network, at least locally, right? Because right now with routing is having one network talk to another network. So if I wanted to talk outside of my own local area network, then I would need a router to route me so I can talk in the quote unquote the internet, right? So I can talk to people that is not local to me. So let's just go over that really quick. Now I'm gonna just try to draw my best. So we have a computer A, and we have computer B, right? These two will be connected to let me make that a little better. Little A, little B, and then we have a switch, right? Because again, we're always talking about enterprise networking. We're not going to talk about we're not talking small scale. So we're always going to have a switch here, which connects to A and connects to B. All right. Now, if computer A wants to send computer B some information, computer A is going to create a frame, right? What is a frame? Encapsulated data. Okay. So A, let me just put it over here because I want to draw the whole frame out. So A, the computer, I'm going to type, let's say I'm A. A is going to say, hey, I want to send B good morning. So the computer A is going to create a frame, right? And it's going to encapsulate the data, right? So we got our data. Our data is L3. Our data means that it's routing. It's on layer 3. What is layer 3? Layer 3 is networking, right? It's how we're actually going to route data from, one part of the world to the next, or just simple outside of our local network. So we have our layer 3 data, which is good morning, right? And it's going to get wrapped up into our frame. And our frame has other means of data. Other means of data. However, we just want to worry about the MAC addressing, right? Because frame L2 is all about what? MAC addressing. L3 is about IP address. So this is where the IP address is going to go. This is what we're going to talk about. But before we even get into that, I want to make sure that you guys understand how a frame travels through the network, how data travels through the network, right? On a high level. So we have our source MAC. I think the source MAC is first. Source MAC and our destination. Okay. Now, each device only knows, at least each device, networking equipment only knows the next device in line to send it to. Okay. So when A creates this frame, it has this packet, L3 packet, and it encapsulates data over, and that's the L2 frame. So you're going to have the source MAC and the destination MAC. That's the MAC address. We already know what MAC addressing is. It is the physical address, right? It is your physical burnt-in address. Every single device has a unique MAC address. There's no two. But the IP addressing, you can use multiples. Like I can use the same MAC address as you're using, just as long as we're not routing on the internet. Okay. So we have our MACs. So when the computer sends out this frame, it's going to send it out to this interface. It's going to send it to this switch. The switch is going to look at the source MAC and say, oh, it came from A. And it's going to look at the destination MAC. It's going to say, oh, this belongs to. Now, the destination MAC address is going to be the switch's MAC address. Now, you would think it would be computer's B MAC address, but it's not, because A has to send this data to the switch, and the switch is going to take this off because that came from A. Cool. It's going to put it on its MAC table, and then it's going to read this, going to say, oh, it's to me. So it's going to take this off. Of course, it's going to have some data. We already went through that, but it's going to get to this layer 3 data. This layer 3 data is going to have an IP address on it. That switch does not know how to read IP addresses. Or let's say the switch is an L3 switch and it can read IP addresses. It's going to see that this IP address is not to the switch. It's actually to somewhere else. Now we're not going. We know this to be, but the switch don't know it's to be. So what the switch has to do is ARP, right? We talked about ARP, Address Resolution Protocol. Is going to say, hey, I need to find the MAC address to this IP in this data here, this IP address. I need to find the MAC address because the only way I can forward this frame. I have to forward this frame. The only way I can do that is what we call a frame rewrite, right? So it's going to rewrite the frame. It's going to say, okay, where after it does the ARP, what's the MAC address? So it's going to do an ARP. We already know the ARP is a call. It's going to say, hey, I have an IP address. Who did this belong to? So as it ARPs out, obviously B is going to say, well, that's my IP address. Once it sends a message to the switch and says, this is my address, the switch is going to say, oh, okay, thank you for that. Now I have your MAC because you sent me a message back. So now I have your MAC address, and I'm going to put that on my MAC address table. And then what I'm going to do is I'm going to frame rewrite. So the data layer 3 is still here. It's still here. It can't be open because this is an IP address. And the only IP address can open this is the one that it belongs to, and it's not the switch. So the switch is going to create a whole nother frame, right? It's going to put source MAC, and it's going to put destination MAC. This time, the source is the switch's MAC address, right? And the destination MAC address is who the switch found out who this IP belongs to, which is B. So the destination MAC will say, computer B, PCB, and this source MAC will be the switch MAC. Okay, the switch's MAC. So once it do the frame rewrite, now it can send out that data to computer B, and the computer B will say, oh, that came from the switch. Okay. And then this came destination. Oh, that's me. Oh, okay, let me take that down. And it's going to keep going through some more data, and it's going to finally get to the layer 3 payload, the actual data. And it's going to say, oh, because if you guys don't remember, oh, I'm sorry, where we at? If you guys don't remember, then on a frame inside the payload has the same thing. It has a source IP and a destination IP. So it's going to rip all this off and then come into the layer 3 data and say, okay, here's my source IP address. Oh, so it came from computer A. Okay. And then here's my destination IP address. That's me. Okay. Now I can open this payload and it says good morning. So now the same thing is going to happen, but in reverse when computer B wants to send information. Okay. Hopefully I didn't confuse you too much. But what we're going to do is add in a routing device. Okay. So now we have a router. Okay. That's my best interpretation of a router. So A wants to send information to B, but it's going to go to a router. So it's going to be the same thing. And that's what we're going to learn now is how does the router make forwarding decisions? Because we see that the switch only cares about the layer 2 frame, right? Encapsulated data, layer 2 frame. A frame means layer 2 data. Then inside the frame, we have the payload. We have the actual layer 3 data, the IP address. Okay, both source and destination. Now, what my mentor kind of explained to me, which was kind of weird, but it kind of stuck with me. So what he said is, so the way that the frame and packet travels through the network is almost like an envelope that is put inside of a box. Okay. Now this box, let's just think about it like a regular Amazon box, right? And this cardboard box. This cardboard box on the label, it has a source MAC, right? The MAC address of who did it directly just come from, and then a destination MAC of who it is going to next. But the envelope says who this actual belonged to, and inside the envelope is the letter. Right? It's the actual data, it's the actual message. But on the letter is who it actually belongs to. It will not change who's on this letter, but it will change who's on this Amazon box. It's going to change source and destination. It's going to keep changing as it goes through all of these networking equipments. It could be like, this is a switch, that's a switch. It's going to go through all of that. Let's just say that's going to be. These are all switches. The frame is going to keep rewriting source MAC, destination MAC, source MAC, destination MAC to the next one, to the next equipment in line, to the next switch in line, until it says, okay, I finally found this address, which through the frame, we only have an IP address because the switch is going to say, well, this is to me. This is my destination MAC. Let me open this box and look at this envelope. And then the envelope is going to have an IP address that does not belong to the switch. So the switch has no choice but to ARP, because switches do not read IP addresses. So we have to do an address resolution protocol attempt so I can get the MAC address that's associated to this IP address, and then I can send it. Then I can rewrite and say, well, the source MAC is me and the destination MAC is computer B. So when computer B, which is an L3 device, right? A computer is L3 device. It is capable of routing data. It's going to have this destination MAC. So when it takes off this frame and looks into this envelope, looks at this payload, it's going to say, oh, well, that IP address is mine. So I actually can go ahead and open this envelope. Okay. Hopefully that didn't confuse you guys, but that is how at least an L2 frame travels through the network, right? A local network, because L2 means it's not only internet. L2 means local. Okay. So today we're going to talk about this L3 payload data. Now, excuse me. Now, before we can talk about actually interpreting the routing table and all that stuff, we want to know the concept of routing, right? What is the concept of routing? Routing is the concept of transmitting a packet through the network. That's all it is. So when someone says, hey, not someone, when you are, let's say a network engineer, and you're trying to figure out, the routing, what's happening with the data, all you're figuring out is, where are these packets going in the network? Where are they transmitting, right? Where are they trying to go? Where are they coming from, right? That's really all as a network engineer you're really paying attention to, right? Like, you are specialized. You are the one that specializes in, data being transmitted through whatever network. So you need to, so you're troubleshooting, hey, you're probably using things like Wireshark to sniff out packets to see what's going on with this. What does this packet say? Why is it not making to this destination? Or why is it making to this destination? Okay. When packets travel through a network, it uses IP addressing. Okay. That is their way of, speaking. Routers look at the IP address and they transmit it through IPs. That's why we were subnetting and all that stuff, so you guys can understand IP addresses, how we don't have a lot of IPv4 addresses, yet we can use private ones to talk in our network, because when we talk outside of our network, we need public IP addresses. So we can, again, it's just like an address. So we can know, where's this coming from? Where is it going to? Okay. And like I said, and like this says, usually the concept is between hardware devices like routers. So just right here, you can see a router, and a router will have a data table that'll say, okay, these are all the routes I know about. I know about this route, that route, that route, that route. So when data comes to this router, the router's going to look at its router table and say, oh, well, I know how to get to these destinations. You go out this interface. Oh, I know how to get to these destinations. You go to that one. You go to whatever, So the routers literally is routing. It is routing those packets via the IP address. All right. Now we kind of talked about this a little bit, which is, if I'm speaking within my network locally, all I need is a switch. I don't need the router to send data to someone that's on my LAN. But if I'm sending something remote, or if I'm a remote worker, then I'm always going to use a router to get into the company's network. Or I'm going to use a router to get outside of my network. So I can't talk to who's ever in the internet, right? You can talk to everyone around the world. Okay. Now that data, them data tables that routers have, is called a routing table. So this is kind of like a little like diagram here. With one, right, we have a IP packet with data. Now, obviously, this will be encapsulated. That's an L2 frame. Okay. But the router obviously is going to have that MAC address. It's going to belong to the router. So the router is going to take that frame off anyway. So I'm going to go ahead and just take that frame off anyway. And then the router is going to look at the IP, the source IP and the destination IP, and figure out, where should I take it? So as it takes off this data, takes off the L2 frame, you see it has the IP packet with data. That's all that's left. So they're reading the IP address. So it came from here and it wants to go here. Once it sees that, it's going to look at its routing table and match up the routing table, the data table. It is going to show all different types of IP addresses and, like you say up here, all different IP addresses and where to go. So it's going to look at its table and see if it knows where to go. Obviously, it's going to be in the next device in line because it cannot see anything outside. The router, the switch, does not know that it's a million devices that it has to route through. They only know they only know where it came from, who sent them data, and the next device in line. That's all they know. So if the next device in line or the next device that's connected to them is not in their routing table, then it's not going to route. It's just going to be a dead packet and it's going to die. Okay. Not going to go anywhere. Now let's go a little deeper into the routing table because that's what we're really talking about today. Hopefully it's not too blurry for you, but on a routing table, this is exactly what you will see. You'll see multiple lines of routes. And it starts with this. It starts with a route code, a route source. A route source, okay? That route source can be, it's a letter, right? So it's either like L, which is local. I think C equals connected. And then they'll have like O, which we'll talk about, which is OSPF. It's a routing protocol. S, static, which you should know. I think in one of these, it shows you, or even in the book, honestly. In the book, it'll show you the different ones. Actually, let me come down here. Let's see. Oh, okay, so yes, actually, these are the protocols. But as far as this routing source, where it starts with, it'll start with one of these, right? One of these protocols. It'll either say R for RIP, which is a protocol. We probably won't talk about that because it's old and it's legacy, and I don't think any switch uses it anymore. OSPF, S for static, D for directly connected, or I may even say C for connected. Let me see. Oh, nope. Hold on, let me look over here. So this is the blog. This got way more information, which is actually good. We should have started here. Okay, here we go. So when you hop on a router, which we'll see tomorrow. I don't want us to get into any labbing today because I want you to really understand the concept of routing and how to interpret that. So when you go on your router, we're going to do a command. As you can see, it is show IP route, right? And it's going to show basically the routing table of that router. What routes do that router know? And from this example, this router knows all these routes. So it has an S, which is a static route. It has a connected route, which means directly connected. L for local. It has R for a routing protocol, RIP. C, I believe that's just connected. Local, I think that's just directly connected. And then, C, the same thing. So these are where the routes were learned from. They were learned from these protocols. Because the router don't just have intelligence, it has intelligence, but once you take it out the box, it's just not going to start routing data for you. You have to set it up. You have to tell the router where to route traffic. So are you going to tell it to route it in a static way, which is, I want you to go here? Is it connected because the interface had an IP address on it and it's connected to another device? Or did I put in a dynamic routing protocol, which in this example is RIP? Okay. So it's going to start with a source. Where did this route come from? Then the second thing you're going to see is the destination network, right? Where this network, where is it going, right? And as you can see here, we have a destination. So it's the network. And as you can see, /24, /32, /28, they're /30. They are subnetted, right? They're not fully classful. because it's a /30. However, these are the networks, right? This is the whole network that that we can route to. So any IP address, that's why we were subnetting, right? Because you take one IP address and you subnet it, meaning that you break it into multiple different IP addresses, multiple different networks. So we're going to take the 172.16.0.0/16, right? That's a classful network. That's a network. But if we wanted to, route to any IP addresses, because we were subnetting, right? We need multiple IPs. We need multiple little networks. So we took this IP and we broke it down. And then we were able to divvy out the smaller IP addresses to computers. So if a computer had a 172.16.1.1/16, then it's part of this network. And it's going to get routed via whatever it's connected to. And it looks like maybe it can be connected to one of these interfaces, serial 0/0/1. Okay. And you can see here, this network is subnetted and it has 5 subnets and 3 masks. So as you can see that this is broken down into all of these networks. So if any of these networks was to route traffic or within this network, I can choose any IP. And if I want to route to that device, I can, because this router knows where to go. Okay. So it's the network, the destination network, or the whole network of wherever you're trying to go. Okay. So the next thing, we talked about route source, we talked about destination, and we talked about administrative distance. So if we look here, administrative distance is basically the most, how can I put this? The most trusted way for the data to travel. So we have a 120, it's always in numbers, right? Here's the numbers right here. So if it's directly connected, this is the best possible route to take. If it's a static route, meaning that the administrator set that route, it's a number 1. And then all these other protocols have their own numbers. So OSPF is 110, RIP is 120. And basically these are saying how trusted they are, how close it is for that packet to take this route. So the lower the number, the preferred value. Okay. When we say 0 or 1, obviously our data is going to take a 0 or a 1, a 0 first, and then a 1. And then it's going to look and see, okay, what's the next possible? Is there internal EIGRP? If it's not, is it OSPF? If it's not, it's going to keep going. Now, again, administrative distance is just the best trusted way for this data to travel, the best trusted route, right? So the router is going to have intelligence, because let's say I created a directly connected route. Let me erase this. Let's say for the router, I directly connected something to the interface, and I also added OSPF as a routing protocol. OSPF is going to say is a dynamic routing protocol. So it's going to help the router learn how to transmit data in a specific way, in a protocol type of way, which is this type of protocol, which we'll talk about. So no, don't get too crazy on what OSPF is. We'll get into it. But the router says, hey, I configured this on the router. So the router is going to say, hey, okay, I have this and I have it directly connected. So if I wanted to send data, we can come right here. If I wanted to send data out, right, it's going to go to this router, and the router is going to say, we're going to look at his table, and it's going to see a 0 and it's going to see a 110. It's going to say, which route should I take to get this data to get to its destination? Now, again, this is already like low key configured into the router already as far as this intelligence. So once you put in the directly connected, once you configure OSPF, the router on its own is going to say, well, the lower the better. The preferred route, that's the lower the better. So I'm going to always send it out of 0, and I'm going to see if anything's better than 110. If there's no static or internal EIGRP, then it's automatically just going to use directly connected in OSPF. And if it has any of these, it's definitely going to use, OSPF or directly connected before any of them, right? So when you're looking at a routing table, and you see the first letter, that's just where the route came from. When you see the second block, that is what networks that the router knows routes to. And then the third one right here, we have administrative distance, which is the preferred route, because the router will learn routes from multiple different sources. They'll have a directly connected, a local, OSPF, a static, they'll have all different types, right? So which route will the router pick to choose to this destination? Because there's multiple routes to this destination, just like GPS, there's multiple ways to get to the corner store, but which route are you going to take? Are you going to take the one where there's a traffic light? Are you going to take the one where there's a stop sign? You're going to take where there's no traffic light, no stop sign. You could just go straight through, So that is basically what administrative distance is telling you. And that's what the number is saying. The number is kind of going to reflect the route source. If you can see 120R, 120R, see? So it's going to kind of reflect the same thing anyway, administrative distance and the route source. And then we have the fourth thing is metric. Now, metric is basically, let me see. Metric is the best path to the network within a routing protocol. So we come back here. So the metric is saying, okay, well, since you're using RIP or you're using OSPF, what's the best way within that OSPF can I route? Because let's say I know 5 routes via OSPF to the same place. Which one of those OSPF routes am I going to choose? I'm going to choose the best one based off the metric. And OSPF has a metric of bandwidth. I don't know, why is that a little... Okay, there we go. Sorry, y'all. But OSPF has a metric of bandwidth, and ERGP metric is K values, and RIP metric is hop count. So how many hop counts do I have? What's the bandwidth or cost? Almost like spanning tree, right? Which one costs less to send this packet through to this route? And then K values, ERGP. I don't think we're going to talk about ERGRP, but they have K values, which probably wouldn't hurt to learn. Anyway, we'll get into that. But yes, so we have administrative distance, which is the best preferred route. The lower the value, the most preferred route it is. And then once we select the administrative distance, if there's multiple routes learned by the same protocol, then we're going to talk about metrics. And metrics come in with obviously the same protocol, because my administrative distance, my AD says that I'm going to use OSPF. So, okay, the router is going to use OSPF, but now we have multiple OSPF routes. So now how do we route? Well, bandwidth and cost. What's the least cost, right? Which is considered in bandwidth. That's how we determine cost. Now, the router does this. The router is intelligent and is going to do this automatically as you configure protocols on there. So it's nothing that you got to actually put in and say, oh, well, the router, you can change your AD, but that's because as an administrator, you want to. But that's nothing that you have to do in order for your data to travel. You just have to configure it, which is configure protocols, either static protocols or dynamic protocols, because the router just don't know how to the router just don't route traffic. You have to tell it how to route traffic. But when you tell it how to route traffic, it's going to use its own intelligence to come up with these values. Okay. We just need to understand these values in case we say, hey, actually, I don't want my data to go out this way. I don't want it to hit these routers. I want it to come out this way and hit, this router. That's where I want it to go. So then I would come in and I would go into, let's say, router A and change an administrative distance because I wanted to take a route that I wanted to take. I don't want the router to come up with its own learning intelligence and do what it wants. And that could be for a certain reason. I don't know why you would do that. Maybe, you know what I'm saying? I don't know. but you always want to have less work as possible on yourself. So you would just set up a dynamic routing protocol and allow these routes to be learned and routed the best way that the router sees fit. Okay, so that's metric. And then it's going to say, okay, so I have this route from OSPF and I know, and it goes to this network, right? The administrative distance, this is the preferred way. This is the metric in that preferred way. Via, so this network, this destination network is via this next hop. Next hop can kind of be, self-explanatory. The next device in line. So if it was this router, what's the next hop? This router. What's the next hop? That router. What's the next hop? That router. Okay, it's just telling you what's next in line because that's all the routers see. The router don't see the whole network. They just see what's connected, what's next in line. So this IP address, which is this router's IP address, is the next hop. It is the next router in line. So I can get to this destination network via this router. That's the name of the router, is this IP address, which is probably directly connected, through interfaces. And then, of course, lastly, the timestamp, when was this connected? That's why we have the same thing as like Mac learning and back aging. And this is the outgoing interface, serial 0/0/0. So let's just, for instance, let me erase this. So for instance, let's say that it's this router that we're looking at, router A, and it's telling you the next hop, and this is the next hop. This is the next one in line. It's giving you the IP address, and it's telling you that the outgoing interface is outgoing because this is the next hop. So it's outgoing, not incoming, right? So the outgoing interface is via this serial, via this, whatever the interface is called, which is usually on a router, something serial, something gigabit. The serial. Huh? Say it again. No? Y'all good? Okay. But yeah, so basically it's going out of this outgoing interface. So this is the next hop via this outgoing interface. Okay, via this little interface here, which again, on a router is either gigabit or serial. It's most likely not going to be a fast Ethernet interface, right? Because it's a router. So that's essentially how you interpret a routing table. So on the exam, you will definitely, probably in interviews, you will definitely get asked about routing tables and how data travels through the network, right? But the first thing is to understand how the data travels through the network. We already understand on the layer 2 level, right? The switch is just going to rewrite the frame over and over again. But for layer 3, we have something called a routing table on the routers. And the routers is multiple lines of these. We can look at it right here. Oh, multiple lines. Let me erase that. Oh, that's a lot. Multiple lines. Multiple lines. You can see multiple lines of what? Of this right here. Of where did this come from? What's the destination? I know this network. So when you see this, you should be able to say, okay, so the router is saying that they know this network. It came from this protocol. This is, basically the best possible route, which is kind of the same goes here, right? Route source, kind of the same thing. So I know this network from this protocol, and it's via this next hop. That's how. So if anybody needs to go to 172.16.4.0/28, if you're in that network, I can send data to that network because I'm connected to a router, which is 209.165.200.226. And it's the serial, it's the interface serial 0/0/0. That's all the router's saying. I know this route. I can send data to this network via this. This is very important that you understand this, because this is kind of like the whole concept of network engineering, honestly. If you don't understand this, then everything else kind of is like, It doesn't make sense, right? Just like with subnetting. If you don't understand subnetting, if you don't know how to subnet, or you don't understand the concept of subnetting, at least that part, then you're not going to understand the destination network is this via this IP address. So if I want to send data to 172.16.4.1, I'm trying to send data here. This is the PC that I'm trying to send data to. And then you come and look at this routing table, you're going to be like, well, I'm looking for this IP address, but that's probably why you can't get any data, because there's no IP address. When that's not how you should be thinking. You should be thinking in a network term, to where it's like, okay, well, is this network, not this IP address, is this network on the routing table? Well, you know how to subnet. So you already know, like, okay, well, if we're in a slash, 28, then 1, 2, that's 8, that's 16, that's 24. That means that this right here is the network that we're looking for. We don't care about anything else. We just care about the first 3 octets. So is the first 3 octets here on this routing table? Yes, it is. So yeah, the router knows the route to send it to that PC. So let's see, why is it not getting to that PC? Why is the data not getting to that PC? Because the router has it. That's number 1 troubleshooting right there. That's like, perfect network engineer. So I would suggest definitely making sure you know how to interpret this routing table as such. Now, static routes let's just say static routes. Static routes is something we will do tomorrow, because I actually want to sit here and do a little configuring with you guys. But, excuse me, we have these different static routes for IPv4: default, network, host, and floating. All right. A static route is just saying that you're going to start with the command IP route. So of course you're going to go into enable, and you're going to go in conft, right? And then you're going to put in IP route, and you're going to put in the route that you want. Now we could say default route. This is a default route, 0000000. As you can see, it's the IP address and the mask. Why is it 0? Because that's saying that if you don't, it's saying that the default route, anything that is not specified, should be defaulted to go here. That's why it's all zeros. And then once you put all zeros, you're going to actually put the next hop or the exit interface. So the next hop is whatever the IP of the next router is, right? It could be anything. It could be 10.1.1.1, which probably it wouldn't, but just for example sakes, that's what you would put there. You'll put IP route 0.0.0.0 space 0.0.0.0. Messed that one up right there. And then space, and then you will put the IP address of the router that's in line. Okay. Again, I am telling the router where to route traffic, because the router don't know that much. The router has intelligence, but that much intelligence. Okay. Then we have the network route, right? So I'm going to say IP route. That's where you start off when you want to tell the router what routes to take, at least for static routing. And you're going to put in the network. What's the network address? You're going to put in the mask, the subnet mask, /24/12/16. I don't know. You're going to put it in decimal form. So it's either going to be 255.128.0.0 or 255.255. Whatever. Okay. And then, as you can see here, this is what it will look like. So you'll put IP route, the network, the mask, and the next hop. Kind of like the default route, right? But the default route is always going to be just zeros because it's default. The network says route to this network. Host, same thing, but we're routing to a host. So you're going to put the host, and then you're going to put the mask. Host mask is usually /32. So as you can see, 255, and then the next hop or exit interface. When we say exit interface, it could be something like serial 0/0/0. Or you can actually put the IP address. Okay, it's better to put the IP address because anything can happen with this interface. So IPs are always just good to default to. Excuse me. And then the floating static route. Floating static route is basically you're just changing an AD of a route. As you can see, you got to put the AD here, and you would always put it under 1 or actually you could put it anything. You could just put it whatever you want it to go to. So let's say I wanted to change the AD. I want to have a floating static route. So I would probably put it like maybe 110 because not 110, 111, because I want OSP to route the best way. But if it's not OSPF, I don't want it to use anything else. I don't want it to use RIP or external EIGRP. So I'm going to use AD that's greater than OSPF because, again, lower values is preferred route. So I want it to use OSPF, but I don't want it to use any of these other protocols that's attached. So I'm gonna configure a floating static route to say use this AD, right? Don't use anything above it. Use this. That's if this is the smallest you can get to. This is the most preferred, the most lower value you can get to. Okay. And then this is kind of like a little diagram. You can kind of see it here. We're going to the router, and we literally put in our static route, which is our IP route, first command, the network address, second command, subnet mask, our third command, and an IP address, which is the next hop, right? Fourth command. And it looks something like this. Or something like this. The only difference is this one has the exit interface. This one has an IP address. Okay. We'll do these tomorrow. I would really honestly suggest you guys can kind of do it tonight to, get a little spun up, but we will do some more tomorrow. I'm also send you guys, it's already in the Notion, but it's kind of what we just already went through, right? The concept of routing, right? The concept of transmitting a packet through the network. Routing has 3 elements: a protocol, an algorithm, and a database. The protocol, we keep talking about OSPF, and we're going to talk about that probably on Wednesday. That's a protocol. Okay, it's saying this is how you're going to do something. What is a protocol? It's telling you how you do something. Routing also has an algorithm to determine the path to travel, which is the metric. Routing has a database, a forwarding decision. How does it make these decisions? Through an administrative distance. And that administrative distance is coupled with a metric. So it's protocol first, and then the administrative distance, and then the metric. And then it can send out the data, how it needs to send it out. But it's going to check these 3 things first. Okay. Types of routing protocols. Now I said we're going to talk about OSPF. I don't think, let me just look here. OSPF, only version 2. And then, okay. So no, y'all don't need to know EIGRP and stuff. Because I definitely learned that. I learned all these protocols, which is good. I mean, you're going to learn them anyway as an engineer. And you're going to learn them on the job, so it doesn't matter. Okay, cool. So we don't even have to go into that. We don't even have to touch that. So routing protocol, we'll talk about OSPF, but OSPF and other protocols like RIP or IGRP, they're either link state or distant vector. Okay. All of these protocols are interior gateway protocol. Okay. That means that they exchange information within each other. Okay. That's what that means. So it's router, and let's say this is AT&T's network. So that means that, let's say AT&T network. So if they're routing, I'm gonna act like this is that right here. So if they're routing, they're exchanging information within a system that's managed by AT&T, right? But if we're talking about exterior gateway protocol, which we'll talk about these terms more. So, this is just getting acclimated to it. When we're talking about exterior gateway protocol, that means that, I'm gonna just draw over here. This probably is AT&T. Who's AT&T? Let's say T-Mobile, right? This is T-Mobile's network. Whatever, you know what I'm trying to draw. This T-Mobile's network. So if T-Mobile network wanted to route information with AT&T network and vice versa, it would be called an exterior gateway protocol. Because we need a protocol for this. We have a protocol for this. Let's say T-Mobile uses RIP. I don't know. And let's say AT&T uses OSPF. But to talk between each other, they need a protocol. And what protocol is that? People like to call that the internet. Well, we as network engineers, we actually call this the internet, right? When two autonomous systems talk between each other, not within each other, but between each other. Two systems that are managed by two totally different enterprises. They're talking to each other. They need some protocol to talk to each other, because if my router's talking, your router's talking, how do we get our routers to talk together? We use a protocol called Border Gateway Protocol. We call this the protocol of the internet. That's what we call this as engineers, as network engineers, because this protocol is what routes everybody together, right? It is Border Gateway Protocol, used to exchange routing information between autonomous systems on the internet. It is the only one that is an EGP. It is the only protocol. Please, that should be like stuck in your head. Please, BGP is what that is. You are supposed to know about BGP when you get to like professional level or even expert level. So we don't even really have to go in on BGP, but you definitely need to know that it's a gateway protocol. It's an exterior gateway protocol that talks between systems that are not managed by the same company. So let's say maybe if you was working with Turner and then you was working with Comcast, they're probably the same people, but we are working with those two different companies. They still have to talk to each other, and they're going to talk to each other through a certain protocol. And whoever probably owns the whole thing is the one that you're going to, ones that's going to configure this protocol. So it's like, layers on layers, right? Because you may have an internet service provider that's AT&T is who you pay your bill to, but AT&T is actually encompassed with a whole nother service provider, which can be Comcast or something. T-Mobile is kind of like that. T-Mobile, I worked for them, and they not only have their own network that they manage, but they manage outside networks. So they're connected with Sprint. Sprint is moved over to them, and they were connected with another phone company, I forgot, but they're more like a service provider. So you may work for a company like Vanguard, right? I work for them. May work for them, and that's in their network. But to speak to everyone else in the world, you're going to talk to a service provider, and that service provider can be T-Mobile, it can be Comcast, it can be Bandwidth. Bandwidth is very big. You're probably going to see that out in the field. And there's a lot of companies that deal with BGP. So make sure you understand that. We're not going to go in on this because that's more OSPF, but at least you guys can review it and not be, too green on it when we go over it on Wednesday. It tells you a little more about vector, distance vector, and link state, like what's the difference. And then, yeah, this goes in with metric. This goes in with administrative distance. And components of a routing table. Each router maintains a routing table and stores it in the RAM. Please know what RAM is. RAM and ROM, know the difference. They're not the same. And then, of course, the routing table. And we kind of went over this already. The routing source populates a routing table automatically, statically, or dynamically. Please know that that's how the router will get information on its routing table. Dynamic is like OSPF, right? Or RIP. Static is what we was just talking about, actually putting in the route, and automatically is connected, right? Because if it's connected, they're gonna know. Static and dynamic, the difference. And then the same thing with configuring. But I tried to give you guys a lot of diagrams because I'm a visual learner. So you can talk all day like this, but unless I'm actually seeing a diagram of how this flows, then it just doesn't make sense to me. So this is kind of something that hopefully you guys, it makes sense to you, right? We have our dynamic routing protocols. We have either IGPs or EGPs. There's only one external. There's only one protocol for the internet, BGP. But as you can see over here, we have other ones. We have OSPF, ISIS. We don't really use that. That's some old stuff. What is this? What's IS? Oh, intermediate system to intermediate system. I don't know if that's Cisco. And then EIGRP, which is Cisco. We don't even use that anymore. Well, actually, you probably will see companies use this. And then RIP version 2, which is routing information protocol. It was the first ever protocol. Just a little history for y'all. RIP was the first ever routing protocol. Then version 2 came out. And then, of course, we have IGRP, then EGRP, and then these start coming out, right? But yeah, that's it, right? I just really wanted you guys to understand, understand the components of a routing table. So when you come to your exam list, you should know exactly the routing protocol code, right? Whether it's R, S, D, C, O, the prefix, the network mask, the next hop, right? What is the next hop? Administrative distance. What is administrative distance? Metric. What is gateway of last resort? Right? Gateway of last resort is just when the router doesn't have any other path to take to a packet, something like that. It's in the blog, but it's basically like a default route. And then determine how a router makes the forwarding decisions. The longest match, which is the administrative distance, and the routing protocol metric, right? It's kind of the same thing. They just repeated it, but they want you to understand that one, you need to interpret components of this routing table. When you see it, what it looks like, can you read it? And then when the router makes a forwarding decision, by default, how does it do that? Because we're going to look at the network, the longest match of the network, right? That's where we got the subnetting that come in. That's why we have the subnet mask, right? So if something is a /12, then you know the router can use the /13 or maybe a /14 or maybe a /11 to get to the network, because that's the closest, that's the longest match. We'll talk about that more, no worries. And then administrative distance and routing protocol metrics, which is the same things here, right? It's going to use the AD and the metric to see, where can I send this data? What's the best route to where it's not going to take the longest time and it's not going to fail? Okay, that's where the AD and metric come in at. Okay, and then let's see. We have a lab. Oh yes, a lab. I really want you guys to do reading today, but for labbing, if you want to take a stab at it, let's do this lab. I had to make sure it was good today. So let me go ahead and do control copy and put it in here. So you guys can have a lab. Static routing lab, configure, as you can see, configure basic router settings, configure basic router settings. That's really it is. And it has the answers. So it shouldn't be that hard. So that's the lab. You can do it. We'll do it tomorrow as well. And then flashcards. Flashcards are updated. So routing basics. So make sure you go through them. I love the flashcards because it's gonna help you. Let's see, dismiss. I don't know what's happening. Oh, routing between VLANs can be accomplished 3 ways. What is a default gateway? IEEE 802.1q. The show IP route command. What does it do? Displays the RIP routes installed on the route table. I don't know why it says specifically RIP, but whatever. Administrative distance in Cisco routers, a means for one router to choose between multiple routes to reach the same subnet when those routes are learned by different routing protocols. The lower the administrative distance, the better the source of the routing information. Okay. In a network mask, the ones correspond to the, right? Next hop and a whole bunch of other stuff. Ew, gateway of last resort. Let me see. The IP address of the router and your network where the data packets are unknown. Right. So if they don't know where to route, they're going to use the gateway of last resort. It's that IP address that it'll route through. Routing table, default route. Okay. So this is something that you definitely need to make sure that you understand. Okay. And yeah, that's it. We will actually tomorrow just do labbing. So I want to make sure that you guys can see this on a lab. Where we at? See this. Let me see. Yep, configure and verify IPv4 and v6 static routing. It's important that you know how to it's important that you know these commands because they will be on the exam. The exam is definitely going to test the commands that you know. And these commands low-key should be something that you know just honestly, in your head, right? And then Wednesday, we will configure and verify OSPF. We'll talk about these things. And Thursday, we will talk about the first hot redundancy protocol. So we'll get into a lot of configuring. Oh, actually, this is describe. So they don't even want us to configure. They just want us to describe it, which is good, because when you start configuring first hot redundancy protocols and more on OSPF and EIGRP, you're becoming more like a professional or an expert. And then, yeah, you can definitely get paid the big bucks. So just knowing this basic information will get you something like a little under 100 an hour, right? Maybe like 80, 70 an hour. But if you know exactly how to configure first hot redundancy and know how to configure protocols outside of OSPF, hey, probably if you could just do configure OSPF, you're definitely looking at like $175 an hour, $200 an hour, almost 400K salary. And then we'll go into week 4. Week 4 is my favorite week because I love DHCP. I'm a nerd for DHCP. I love NTP, network time, and I love network time protocol and DNS because I deal with DNS all day, every day. I build websites for my clients. So DNS is like something that I do all the time. I go to GoDaddy. I change their DNS settings when they want their domain to be public, right? So it's good to know this too, because hey, maybe you can make it a business as well. So yeah, this is my favorite section. And then security. Tommy, you might want to hop in on security because security is pretty fun. And programmability. Programmability is pretty fun as well because we actually get to deal with APIs and Postman and which is something you can add on your resume, and it could be something like something dealing with a Python engineer, something in that sort. Yeah, and then that's it. So yeah, that's all I have for you guys. Make sure you want to do the lab, you can. We're gonna do it together tomorrow anyway, so who cares? Make sure you do these flashcards though. These flashcards is no joke. But yeah, I'm gonna fix this for you guys because I don't know why it's like this. Anyway, let me delete that because that's just
class at 7 or 8 tomorrow.
It's at 8. Let's keep it at 8 because it helps me get everything finished up for my work day, and then I can actually do some labbing. Yeah, 8 p.m. Central Time. Okay. But yeah, any questions on this? It was kind of straightforward, kind of. That's it, nothing. Okay. Well, as you guys know, you can definitely reach out via Discord at any time. And you should be also in the course on the site, so you can at least get some older videos from last class if you want to, get a different type of explanation, because I do explain this different ways in every class. So that's just me and my style. So if you feel like, you know what, I didn't really get this lesson, hop into the technicallyspeaking.com and your profiles and go over, this week, go over IP connectivity and routing tables, and maybe I explained it better last year. But the information is still the same nonetheless. And don't worry, you can always go to YouTube and figure out someone else who explain it. Maybe you can read the Cisco book and actually the chapter, which is probably chapter 7 or 16. I don't know. But go through the chapter and maybe that'll help you out. Not sure, but definitely make sure you understand this stuff. And I can also reiterate if you need. Okay. All right. Well, thank you guys for attending, and until tomorrow. Until tomorrow. Let me stop sharing, y'all. All right. Did I stop? Did I? No. Oh, there we go. Stop recording. You sure you want to stop recording? Yeah.